videos on the heat of reaction for a neutralization reaction.
In the Heat of Neutralization Lab, the objective was to determine whether a neutralization reaction between hydrochloric acid, a very acidic substance with a low pH, and sodium hydroxide, a very basic substance with a high pH, would be exothermic or endothermic, and precisely how many joules of energy were either produced or absorbed from the surroundings. The surroundings in this experiment were simply composed of the solution itself. We neutralized 20 milliliters of 1 molarity hydrochloric acid and likewise for the sodium hydroxide. For consistency, a balance is used to measure equal masses of the sodium hydroxide and hydrochloric acid, as in this lab we considered 1 gram to be equivalent to 1 milliliter. Heat, or thermal energy, is an important factor in many facets of chemistry. In reactions specifically, heat can either be necessary for the reaction to occur, this type of reaction is defined as endothermic, or the reaction itself can give off heat, this type of reaction is exothermic. The heat produced or used by reactions varies greatly depending on the substances involved and the process by which the reaction is facilitated. In a reaction, if the temperature change and specific heat capacity are known, the heat of reaction, or enthalpy, can be determined. The specific heat capacity is the amount of heat per 1 gram needed to raise the temperature of the substance by 1 degree Celsius.
During this experiment, we need to be wearing gloves, goggles, and aprons because we are going to be using two chemicals. These chemicals are hydrochloric acid and sodium hydroxide.
The measurement of heat involved in this experiment was possible to measure by using a process known as calorimetry, in which heat transfer is observed. A calorimeter is a piece of equipment in which or with which heat can be measured. It measures calories, which are units of heat energy, reflecting the sample's temperature change. The calorimeter in this lab was composed of a styrofoam cup and temperature probe. The cup holds the sample and allows for minimal heat loss because its foam contains billions of air bubbles and acts as a good insulator. It is also placed in a beaker for sturdiness. The temperature probe measures the temperature of the substance through the lab quest, so the initial and final temperatures can be compared. To quicken the reaction of the substances, the mixture is stirred.
In the procedure, one uses two styrofoam cups and a balance to find the mass of the 1 mole of HCl and 1 mole of NaOH. The styrofoam cups are used to make sure the heat is not released into the surroundings, and it acts as a calorimeter. The initial and final temperature is recorded using a lab quest to get an accurate temperature of the solutions in combined solutions. When the HCl and NaOH solutions are combined, the LabQuest temperature probe gently stirs the solution until the highest temperature is recorded to get an accurate temperature change.
This data table shows the mass and initial temperature of the hydrochloric acid plus the sodium hydroxide. It also shows the final temperature of the combined solutions. As we know, 1 gram of a solution equals 1 milliliter of the same solution. So in order to find the mass of the hydrochloric acid and the sodium hydroxide, all we had to do was measure approximately 20 grams of each solution, which equals the 20 milliliters of the solution that we needed. We also had to find the initial temperature of the two solutions plus the final temperature of the combined solutions in order to find the amount of heat produced in the experiment.
In the calculations, we need to find the theoretical enthalpy of the amount of heat formed in the system for the reaction of sodium hydroxide and hydrochloric acid by using the equation for delta H, or the enthalpy change. We need to calculate the theoretical enthalpy to find the percent error of the number of kilojoules over moles of heat produced. Next, we need to use the specific heat formula, or Q equals mc delta T, to calculate the amount of experimental heat produced. This is used to help find the number of kilojoules over moles of heat produced in the experiment. Then the number of moles of hydrochloric acid and sodium hydroxide used in the experiment are found to determine the limiting reactant. The limiting reactant is then used to help calculate the number of kilojoules over moles of heat produced. With the limiting reactant and heat of experiment, we are able to find the heat produced using the unit of kilojoules over mole. Lastly, we calculate the percent error of the experimental heat produced based on the theoretical to determine how precise our experiment was. In the conclusion, we need to write the net ionic reaction in order to determine that the heat of reaction occurred for a neutralization reaction. Then, we need to write the molecular reaction with the experimental enthalpy to show the amount of heat released in the neutralization reaction. Thanks for watching.